zero point 0.5 kilometers, 80% of the world's human population lives up to this altitude. 2 kilometers, 99% of the world's population lives up to this altitude. 2 to 3 kilometers, the onset of ailments, altitude sickness, in unacclimatized people. 4.7 kilometers, the FAI, Fédération Aéronautique Internationale, requires supplemental oxygen for pilots and passengers. 5.0 kilometers, 50% of the atmospheric pressure at sea level. See standard atmosphere. 5.1 kilometers, the highest permanent human settlement, the city of La Rinconada, Peru. 5.5 kilometers, half of the atmosphere's mass has been passed, Mount Elbrus. Zenith sky brightness is 642 to 1,230 candelas per square meter. 6 kilometers, the boundary of human habitation, temporary Sherpa settlements in the Himalayas, the boundary of life in the mountains. Up to 6.5 kilometers, the snow line in Tibet and the Andes. In all other places, it is located lower. In Antarctica, down to 0 meters above sea level. 6.6 kilometers, the highest located stone structure, Mount Lulayaco, South America. 7 kilometers, the limit of human adaptability to prolonged stays in the mountains. 9.799 kilometers, the boundary of a homogeneous atmosphere at 0 degrees Celsius and uniform density from sea level. Sky brightness decreases in proportion to the decrease in the height of the homogeneous atmosphere at this level. 8.2 kilometers, the death zone boundary without an oxygen mask. Even a healthy and highly trained person can lose consciousness and die at any moment. Zenith sky brightness is 440 to 893 candelas per square meter. 8.848 kilometers, Earth's highest point, Mount Everest, the limit of accessibility on foot towards space. 9 kilometers, the limit of adaptability to short-term breathing of atmospheric air. 10 to 12 kilometers, the boundary between the troposphere and the stratosphere, tropopause, in mid-latitudes. This is also the maximum altitude for regular clouds. Beyond it lies rarefied and dry air. 12 kilometers. Breathing air is equivalent to being in space, the same time of 10 to 20 seconds until loss of consciousness. The limit of short-term breathing of pure oxygen without supplemental pressurization. Zenith sky brightness is 280 to 883 candelas per square meter. The service ceiling for subsonic passenger airliners. 15 to 16 kilometers. Breathing pure oxygen is equivalent to being in space. 10% of the atmosphere's mass remains overhead. The sky turns dark purple, 10 to 15 kilometers. 16 kilometers. When wearing a high-altitude suit in a cabin, additional pressurization is needed. 18.9 to 19.35 kilometers, the Armstrong limit, the beginning of space for the human body. Water boils at human body temperature. Internal fluids do not boil yet, as the body generates enough internal pressure, but saliva and tears may start boiling, forming foam, and eyes may swell. 19 kilometers. The brightness of the dark purple zenith sky is 5% of the brightness of a clear blue sky at sea level, 74.3 to 75 candelas versus 1,490 candelas per meter squared. 20 kilometers. The zone from 20 to 100 kilometers is considered near space by a number of parameters. At these altitudes, the view from the window is almost like in near-Earth space, but satellites do not fly here. The sky is dark purple and black lilac, although it looks black in contrast with the bright sun and surface. The ceiling of hot air balloons, Montgolfiers, 19,811 meters.
20 to 30 kilometers, the beginning of the upper atmosphere. 20 to 22 kilometers, the upper boundary of the biosphere, the limit to which living spores and bacteria can be lifted by winds. 20 to 25 kilometers, the ozone layer in mid-latitudes. Daytime sky brightness is 20 to 40 times less than its sea level, similar to the center of a total solar eclipse path or during twilight when the sun is 2 to 3 degrees below the horizon and planets might be visible. 25 kilometers. The intensity of primary cosmic radiation begins to prevail over secondary radiation generated in the atmosphere. 25 to 26 kilometers. The maximum operational altitude of existing jet aircraft. 29 kilometers. The lowest scientifically determined boundary of the atmosphere based on the law of pressure change and temperature drop with altitude, 19th century. At that time, the stratosphere and temperature inversion were unknown. 30 kilometers. Zenith sky brightness is 20 to 35 candela per square meter, approximately 1% of ground level. Stars are not visible. The brightest planets might be visible. The height of the homogeneous atmosphere above this level is 95 to 100 meters. 30 to 100 kilometers, the middle atmosphere, according to COSPAR terminology. 34.4 kilometers. The average surface pressure of Mars corresponds to this altitude. Nevertheless, this rarefied air is capable of lifting dust with winds, tinting the calm Martian sky a yellow-pink color, with a brightness 100 times greater than calculated in the absence of dust. On Earth, there is no such effect, and the sky remains dark because dust does not rise to such an altitude. 34.668 kilometers. The altitude record for a stratospheric balloon with 2 pilots, Project Stratolab, 1961. Approximately 35 kilometers, or the beginning of space for water, or the triple point of water. At this altitude, atmospheric pressure is 611.657 pascals, and water boils at 0 degrees Celsius, and above this, it cannot exist in a liquid state. 37.8 kilometers. The flight altitude record for turbojet aircraft, MiG-25, dynamic ceiling. Approximately 40 kilometers, or 52,000 paces, the upper boundary of the atmosphere in the 11th century, the first scientific determination of its height based on the duration of twilight and Earth's diameter. Arab scientist Al-Hazen, 965 to 1039. 41.42 kilometers. The altitude record for a single-person stratospheric balloon, as well as the parachute jump altitude record. Alan Eustace, 2014. The previous record was 39 kilometers. Felix Baumgartner, 2012. 45 kilometers, the theoretical limit for a ramjet aircraft. He talks about space. Approximately 80 kilometers, the longest sound waves, up to 30 meters, stop propagating due to rapid attenuation. Shorter sound waves, such as the human voice, 0.25 to 4.28 meters, and especially ultrasound, attenuate at lower altitudes. 80 kilometers, the perigee altitude of an artificial Earth satellite at which orbital decay and deorbiting begin, the onset of recorded g-forces during descent at orbital velocity, Soyuz descent module. 75 to 85 kilometers, the altitude where noctilucent clouds appear, sometimes with a brightness of up to 1 to 3 candela per meter squared. 80.45 kilometers, 50 miles,
the boundary of space according to the U.S. Air Force, NASA adheres to the FAI altitude of 100 kilometers. 80 to 90 kilometers, the boundary between the mesosphere and the thermosphere, mesopause. Sky brightness is 0.08 candela per meter squared. 90 kilometers, the onset of recorded g-forces during descent at escape velocity, second cosmic velocity. 90 to 100 kilometers, the turbopause, below which lies the homosphere, where air mixes and has a uniform composition, and above which is the heterosphere, where there are no winds and air stratifies into layers of gases of different masses. Approximately 100 kilometers, the beginning of the plasmasphere, where ionized air interacts with the magnetosphere. Approximately 100 kilometers, the brightest sodium layer of atmospheric air glow, 10 to 20 kilometers thick. From space, it is observed as a single luminous layer. 100 kilometers, the proven extent of the atmosphere as of 1902 due to the discovery of the Kennelly-Heaviside ionized layer at 90 to 120 kilometers, which reflects radio waves.